All right, so in this module, it's corresponding to the chapter in the book that's talking about stochastic programming and simulation. And rather than kind of, stochastic programming and simulation is really an application of Python. It's not really a new syntactical concept or anything like that. But one of the things that it does rely upon is having randomness, random data for your simulations to work with and eventually perform statistics on and do some calculations. So in this module, I just want to we've used a random library a few times in a couple of our test programs, particularly when we dealt with searching and sorting. This time I want to just give you a little bit more in-depth background concerning random numbers. So, it should be clear that randomness is very useful. It's good for shuffling the order of a list. Lots of times, we'll generate programs that are supposed to kind of quiz a user, maybe practice tests, generating questions from a test bank, randomly coming up with a particular question. You can think of in video games, having enemy eye have some amount of randomness to them, so we can't predict exactly where they're going to go. And in simulation data and scientific data, adding noise to data can be a use of randomness. And we've also seen, just in terms of testing, generating test data. A lot of times in in science, we want to determine whether or not some phenomenon that we're seeing in the data could happen randomly. And so a lot of times we'll also generate random data sets to serve as sort of a control as well. So having random in a program, a random int, a random float, or some sort of, and you can extend this to a random string if you assign characters based on numbers, having the ability to generate random numbers in a program is very valuable and surprisingly useful. Now the problem with random is it's really hard to quantify. If I ask you to randomly think of a number, whatever you blurt out is probably I don't know, is that random? It's hard to really tell. It could be because you were just thinking about some number or something like that. Random is an inherently sort of experiential type concept. It's hard to say whether something's truly random or it could have been predicted, it just was hard to predict, or maybe the observer couldn't have predicted. So when we talk about random in computing, and computers are really bad at random, we need algorithms to generate these things, and if there's an algorithm behind it, it ain't random. A better definition of random numbers in a computer is a number or a sequence of numbers in which the observer, you or whoever is working with the program, couldn't reasonably predict the next number, right? So there's an ordered sequence of numbers that behind the scenes there is actually an algorithm behind it, but it is sufficiently sort of complicated that under typical use case scenarios, it's virtually impossible for you to predict the next number that will come out of the sequence. All right, so that's really a random number. It's called a random number generator, actually. So people have worked really hard on this. It's a very interesting topic in computer science. How do you generate algorithms that create sequences that are unpredictable? And in reality, first off, they're generally based in some way on unique properties of the hardware on a particular machine. Because one of the important things about randomness is that it should behave differently for different people. So it's based off of some serial numbers or something like that. And then there's an algorithm used taking in those type of an input to generate a very, very, very large non-repeating set of numbers. It's sufficiently hard to predict that we can consider them to be random. But actually, as I'll allude to later, we can consider them to be random if we don't care that much. We can actually crack these things. So random in Python, we've actually already seen it. We import the random library. So that's a package in Python, and the core random function is just random. Calling random with no parameters returns some floating point value, some real floating point value of arbitrary precision between 0 and up to including 1.0. So every time you call random, you're going to get a new floating point value. It's not guaranteed to be unique, right? If you call random enough, you will get repeats of the same number. But the key here is that after seeing the first number come back as, 0.81, there's no way for you to predict based on 0.81 what the next call to random will return. All right, and that's the value in this. If you don't want floating point numbers, you can also ask Python for integers. All right, and we've used this. We've had a random integer between 0 and some maximum value. The start and end are arbitrary. You can specify anything you want. And if you say random int between 2 and 45, it will provide you some random value between 2 and 45, and it's inclusive. Actually, random int is really just calling random and then multiplying this number so it fits into a range. The third function that proves pretty useful is if you're trying to choose from a list. So the choice function accepts a list of values, and it will randomly pick one of the list. And so notice this is not a sequence of numbers, but it'll randomly pick index 0, index 1, or index 2. This is really just a convenience function. You don't actually need this. If you had a list of 3 elements, you could just call random int with 0 and 2, and that would give you a random integer between 0 and 2, and then you could apply it as an index. This is just a convenience method. So, it's often that we have to pick random numbers from a list, and rather than going through the exercise of selecting a random int and then applying an index, we could do it this way. But all 3 of these can prove useful in different scenarios. You need to think about what you need, right? What makes the most sense for you in every circumstance. I mentioned that this sequence, and it is really a sequence of numbers, you're calling this function over and over again. It is predetermined, right? So when you start up your machine, the random number generator on your operating system is actually creating the sequence. And the same sequence is used no matter how many times you run a program. It exists independently of your program. In Python, there's an implicit offset into this very, very long sequence of numbers based on the current time, which is useful because then that way every time you run your program, by definition, it's at a different time. So the first time you call random is giving you a number from a different place in that sequence. So you think about this sort of never-ending sequence of numbers. The Python random number generator seeds the list or seeds your position at a place associated with the time. If you manually wanted to do this yourself, typically you don't need to do this. Typically you want random numbers that are offset to different values or starting at different values in the sequence every time you run the program. But if for some reason you didn't want that, you wanted to always start every time you ran your program, you wanted to initially start at the 10th number in the sequence, you could do that. You could say random.seed 10. And that would be useful if you wanted to generate a set of random numbers, but every time you ran the program, you wanted the same set of random numbers. Occasionally that's useful. To be honest with you, I don't think I've ever done that. It doesn't really make a whole lot of sense because the seeding on a different machine wouldn't give you necessarily the same numbers. So it's not a tremendously useful thing, but you should kind of keep it in the back of your mind. Every once in a while, it might be interesting. I actually take that back that I've never done it. The only times I've done that was for debugging. If I wanted to actually debug something and I was noticing a problem on only a certain set of random data, maybe if I was developing a sorting algorithm, I could seed to the same value each time so I could keep that constant. So that might be a useful way to do this. So the last thing I'll say about random, and again, if you're not a computer science major, I think it's sufficient for you to sort of just say, okay, well, when I call random, I get a random number. But if you're pursuing a computer science degree, if you're thinking about, from a CS perspective, the random number generator is not random, as we said, right? There are some fairly sophisticated algorithms behind it, but the thing is that it's breakable. we can develop algorithms to predict the next number. And so there are some, certainly when we're generating random data sets to sort to test our searching capabilities or something like that, that's not really of anybody's concern, right? That it's okay. It's random enough for the general purpose application. But cryptography, which is included in encryption and privacy, SSL certificates, that kind of stuff. Um, they use random numbers, and it's a lot higher stakes, right? So for security implications, if you're generating random numbers and you're relying on it for security purposes, then you have to go elsewhere, and you need to employ better algorithms that are in fact far more computationally expensive. But like I said, for the most part, and certainly for the scope of our course, um, the random number generator that you're going to be able to use in Python and that we have used in the past really provides an excellent way of generating a lot of useful data sets for us, and has a lot of useful implications.